In this video, we're going to look at two things. We're going to look at the powers of I, and then we're going to apply that to see how we can do operations, multiplication, combining like terms, etc. with complex numbers. Let's begin with the powers of I. We know that I, the imaginary number, is the square root of -1. So if that is true, if I is the square root of -1, then we can see some interesting things that happen if we raise I to various powers. So first, if we raise I to the second power, we can imagine that like squaring both sides of this definition. If I square I, if I square -1, then I'm going to get -1, because the square root of -1 squared will just be -1. So if I is the square root of -1, I squared will be -1 itself. Now to get I to the third, I could multiply both sides of this equation by I, right? I times I squared will give us I to the third. -1 times I gives us -I. So that tells us that I to the third power is -I. And then I to the fourth power, if I squared is -1, I squared times I squared is -1 times -1, which we know to be +1. So if I look at the first four powers of I have this interesting progression where I to the first power is I squared is -1, I to the third is -I, and then I to the fourth is 1. Because I to the fourth is 1, this cycle will repeat. So I to the fifth power, if I to the fourth power is 1, I to the fifth power would just be 1 times I. And we get back where we started. So I to the fifth power would be I to the sixth power, -1, I to the seventh power, I to the eighth power, 1, I to the ninth power, I, and on and on and on. So one way we can represent this interesting cycle is kind of like positive I is floating above the real number line. So if our green is the real numbers, positive I is floating on one side of the real number line, negative I we can imagine is floating on the other side, just to visualize. And if I'm starting with I to the first power, I'm up here, and then I can work counterclockwise to find any power of I. So I to the second power is on the real number line. I to the third power is -I. I to the fourth power, we are back on the real number line. I to the fifth power, we're back where we began. So this means that, let's say I was trying to find I to the seventh power. Out of 1, 2, 3, 4, 5, 6, 7, I to the seventh power would be -I. Once we have observed this with our powers of I, then we can apply it to doing operations with the imaginary number or operations with complex numbers. So in this example, I have I squared times the binomial 5x minus 2i, all quantity squared. At first, when I'm working with I can treat it like any other variable. So I could do this expanded distribution, treating I the same way I would treat x or y, following all of my same rules of multiplication, like terms, etc. So if I were to treat this like any other expanded distribution problem, I would get I squared times 25x squared minus 20xi plus 4i squared. Then I could distribute my I squared to each term. And my result is I have 25x squared I squared. I'm just going to put my i's in that orange color. Minus 20x I to the third power plus 4 times I to the fourth power. Sorry, I used two different colors here. So you'll notice up until now, I've just treated I like any other variable. However, we know from our prior page that our powers of I can be re-expressed in terms of I itself. So I squared we know to be -1. I can rewrite this term as 25x squared times -1. I to the third we know to be -I. And I to the fourth power we know to just be 1. Now that I've done this, I see that some of my positive and negative signs have changed. So this would be 25x squared, but now it's -25x squared. I'm going to put the 4 next, plus +4. Then I'm going to put my imaginary terms at the end. This would be plus 20xi. So we can see that when we have imaginary numbers inside of terms that we are combining using multiplication, addition, subtraction, at first we can treat it like any other variable, but then we can often simplify it further based on these special powers of I.